Now, a body is projected vertically upwards with initial velocity 25 meters per second and its acceleration is minus 10 meters per second squared. Find the body's velocity and time in terms of t. Body's velocity. Alright. But everybody be happy that ds dt, or sorry, d2s dt squared is minus 10 when t equals 0. Is that alright? Alright. So, we're going to integrate this to find the, we're going to do minus 10 to t to find out its velocity, okay? So what happens there? What happens when you integrate this? You get minus 10t plus c, and this is its velocity, and velocity is technically the first derivative. Is that okay? What do we know? We know that the velocity is 25 when the t value is 0. Where does it say that? We all good? So then what? 25 equals minus 10 times 0 plus c implies that c equals 25, implies that the velocity, which is equal to ds dt, must equal minus 10t plus 25. Yes, Michael? Sorry, can you speak louder? I couldn't pick up on that.
If they tell you that it's the initial velocity and the acceleration, can you not use v equals t?
No, because it's not linear. The acceleration values are changing all the time. If it's constant acceleration, yes, but applied maths linear velocity won't work here. Okay. Now, next thing, lads, is one sec. Alright, lads. So if I reread the original question, I found out the body's velocity anytime. Now I'm looking for the height. So the height means integrate one more time, doesn't it? So I'm going to get ds equals minus 10t plus 25 dt. Integrate both sides. The integral of ds, anybody?
S.
Just s, and that will equal add 1 to the power, isn't it? Divide by the new power, and then add a constant at the end. So what am I going to end up with here? S equals, oh, for God's sake, S equals minus 5t squared. We cool with that? Did anybody get this? Now, is there any way for me to get rid of that c value? Okay, let's find out. Does it give me any information to get rid of the c value? What information does it give me? Does it say s is 0 and t is 0, as in you start off at ground level? I think that's what it uses, but it doesn't say it. Just give me a sec. Yeah, it does use that. Yeah, poorly designed. It'd have to say that it starts off at ground level, or that where it's launched from is s equals 0. So I put that down to a poorly designed question, but what they're looking for you to do is when s equals 0, t equals 0. Is that alright? So what would that mean? C is 0, doesn't it? I mean, so the C value doesn't matter. Okay, so that's your equation there. Is everybody cool with that? What's the next thing it wants after that then? What does it want after that? The maximum height reached. Sorry? The time it takes to reach the maximum height. Oh, calculus. What shape function is this? N or U? N. N has maximums. What happens to the slope on the maximum? Or better, yeah, what's your velocity at the maximum? Velocity is 0, isn't it? Because you're no longer going upwards. So the first derivative has to equal 0, which is minus 10t plus 25, and that equals 0. This means 25 equals 10t. This implies that t equals... Is everybody happy with t equals 2.5? Now, how do I find the distance it was up? What do I need to do next? Yeah, sub it back into S. And the S equation is right here. So sub it right back in there, and we should get S equals minus 5 times 2.5 squared plus 25 times 2.5, and what do we get then? Anybody? So we said 125 over 4? Okay. All good? Who got it out? Okay. Oh no. Oh no. Oh no, 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 no. Good man, Connor. The height S above the point of projection. So the point of projection is where you started from. So if you throw an object and for let's say S equals 0 when t equals 0, and then you're in the air, let's say S equals 25 when t equals 2. That means S equals 25 means you're 25 meters above the point of projection, alright? Now, the time taken to return to the point of projection, this implies that your height is 0. Does that make sense? Go to your S equation, which is here, and do what? Replace S with, anybody? Replace S with 0. And then multiply both sides by negative. So you get 0 equals 5t squared. You don't have to do that, I would just like to do it. What can I take out of two of these? Left with t minus 5. And then after that, 5t equals 0, t equals 0, or t minus 5 equals 0, and t will have to equal 5. Is that alright? How would you check your answer? If you go to your table function and you do minus 5x squared plus 25x, and you do it from, you just delete the second one, I don't want that. And you do it from 0 to 5. Oh God, give me a second. You do 0 to 5. Oh, sorry, not even 0 to 5. Do 0 to like 20. Step of 1. Where do you know your maximum is? 0, 0, 120, 230, 330. So you notice that your maximum occurs in between 2 and 3. That was our 2.5 from earlier, wasn't it? And when does it hit 0 again? After 5 seconds. So that's proved your answer. Is that alright? Alright, let's move on. This one. The rate at which water rises in a container is given by the following equation. dH dt is 2t minus 3. Where h is measured in centimeters and t is measured in seconds. Find a formula for the height of the water into the container after t seconds, given that there was 4 centimeters of water in the container at the start. Okay, interesting. So, the h to t means how quickly or how fast your rate is going up. Imagine I was pouring water into here, and every second it raises by another 3 seconds. It raises by another 3 centimeters. Does that make sense? Yeah. Every second the water level goes up by another 3. That would mean, say, the h to t equals 3 centimeters per second. Is that okay? But we don't have that. What we have is a formula called 2t minus 3. Is that right? Now how does this formula work? Well, if t equals 2 seconds, what does that mean? Sub in 2, what would you get? 2 times? At 2 seconds, the water would be rising at a rate of 1 centimeter per second. If I was to sub in 5, what would the answer be? At 5 seconds, the water is actually rising at a rate of 7 centimeters per second. So as time goes on, you seem to be pouring more and more water in. It's almost like the start of a bucket. It trickles in at the start, then it all topples in, it rises faster. Okay, now this is the rate. We're looking for the actual height. So what do we need to do? Yeah, we're in the integration chapter. Let's take a wild guess and integrate. Integrate the h. Integrate 2t minus 3 to t. We basically brought up to the t, so it's the h equals 2t minus 3 to t. We all good? Now, next thing, integrate both sides. What do we get here? H, and would everybody be happy with t squared minus 3t? Plus what? Plus c. Now, is there any information that we can get here? H equals 4 when? T equals 0. So what does that mean? Everybody cool with that? What does that mean for the equation? Exactly. We good? Alrighty. Nextly, find the time taken to fill the container if it is 36 centimeters in height. No bother. H equals 36, bring it over to your side. T squared minus 3t. What's that, minus 32? Oh, they're going to make me do a minus b, are they? Alright, I have the answers. Do the minus b, and you get an answer of 7.4, or t equals minus 4.4. Which one should we go for? Does anybody need me to do the minus b formula? Happy days.